Hello class, this is Mr. Hart, and in this podcast we want to continue our discussion on motion. And we've covered the main ideas of position and velocity and acceleration, but there's a couple of more equations that we can use to help us solve some physics problems. And those two equations are on your motion sheet and they're in here. Those two equations are that the change in x is equal to 1/2 times the initial velocity plus the final velocity times time, and the change in position or displacement is equal to initial velocity times time plus 1/2 times the acceleration times the time squared. Okay, so I won't take the time to write down what each one of these variables represents because we've already seen all these variables before. Okay, this is displacement, this is the initial velocity and the final velocity, the time, the acceleration. So these letters mean the exact same things that we've seen before. And so in class we looked at where these equations come from. Again, I won't take the time right now to go through that, but we want to be able to use these equations because they help us solve a lot of cool physics problems. Okay, and the way I like to think about these equations is they kind of help us go up and down a ladder. Let me show you what I mean. Okay, if we think of position, velocity, and acceleration as part of a ladder, okay, terms that we're trying to find in a physics equation, okay, or a physics problem, they represent different rungs of the ladder, and we can use these equations to jump down between the different rungs of the ladder. Okay, so for example, if I have the position of an object and I want to find its velocity, then I need to use this equation. The velocity equals change in x over the change in time. Okay, that's how I jump down the ladder. If I need to go from velocity to acceleration, then I need to use this equation. The acceleration equals the change in velocity over the change in time, which helps me go down the ladder. Okay, these other two equations that we just saw help us go back up the ladder. Okay, so if I have an acceleration and I need the velocity, then I'm going to use this equation right here. The final velocity equals the initial velocity plus acceleration times change in time. And then if I need to go from velocity to position, I use this equation. The position or the change in x equals 1/2 times vi plus vf times t. Okay, and that helps us jump up the ladder. Okay, so we have these cool relationships between going down the ladder and going back up the ladder. And if you notice, every single time that you're going down the ladder, okay, you're going to be dividing by time, okay, in some part of the equation. And if you also notice, if you need to go up the ladder, you're going to be timesing by time in some part of the equation. Okay, and if you take a calculus course, you'll learn why that is. It's called derivatives and integration, but we don't need to worry about that. But just the key idea here is time is a huge component of position, velocity, and acceleration. Okay, and it helps us go up and down the ladder. There was also another equation of change in x equals initial velocity times time plus 1/2 at squared. And that equation actually helps us go from acceleration all the way up to position. Okay, so it helps us jump, two rungs of the ladder from acceleration to position. Okay, so the point is these kinematic equations, as we call them, help us go between these three different quantities. Okay, and so we need to be able to look at a problem, determine what we do and do not know and what we're trying to find, and then determine the equation that we need to use in order to figure that out. Okay, let's go ahead and try a sample problem and see if we can get the right idea. Okay, so for example, let's say we're trying to solve a physics problem. It says that an airplane starts from rest and accelerates at a constant 5 meters per second for 20 seconds before leaving the ground at the end of the runway. How long was the runway? Okay, so just a standard kinematics problem. We need to know what we do and do not know, okay, and what we're trying to find. Okay, well, we know that the airplane starts from rest. Okay, so that's going to tell us that the initial velocity of the airplane is 0 meters per second. Okay, we also know that it accelerates at a constant 5 meters per second. So that tells us the acceleration is 5 meters per second or meters per second squared. Okay, it does this for 20 seconds. Okay, so we know the time is 20 seconds. And I think that's all we know. And last of all, we need to know what we're looking for. It says, well, how long was the runway? What's the distance of the runway? So we're looking for change in x. Okay. So then we look at our equation sheet, look at all the kinematic equations that we have, and we say, okay, which one's got initial velocity, time, acceleration, and change in x? And if you look at that sheet, you'll notice that this equation right here, change in x equals initial velocity times time plus 1/2 at squared, has everything we're looking for. It's got the initial velocity, it's got the time, it's got the acceleration, and it's got change in x. Okay, so that's the equation we want to use. So now we just plug in what we know. So change in x equals vi is 0 in this case, times time, which is still 0, plus 1/2 times 5 for the acceleration, times 20 squared. Okay, so there you go. You put that into your calculator. 0 plus 1/2 times 5 times 20 squared, and they tell you that this runway is 1,000, and this is a displacement, so this is going to be in meters. Okay, so the runway is 1,000 meters long in this problem. Okay, so this is the process we use for every single type of kinematics problem, and for a lot of problems in physics. You identify what variables you do and do not know. You find out what you're looking for, figure out which equation is going to help you find that, plug in what you know, and you get your result. Okay? Let's go ahead and try another one. Let's see if we got this down. Okay? So this problem, an Indy 500 race car's velocity increases from 5 meters per second to 40 meters per second over an interval lasting 10 seconds. How far did the car travel in this time? So again, we look and see what we do and do not know. Okay? So we know that we have an initial velocity of 5 meters per second. Okay? That's what it started at, so 5 meters per second for the initial velocity. We also know that it ends at 40 meters per second. Okay? So that's its final velocity. And we know the time was 10 seconds. So we know the initial velocity is 5 meters per second, we know the final velocity is 40 meters per second, and we know the time is 10 seconds. Okay, we don't know the acceleration or the distance or anything like that. Last thing we do is we say, what are we looking for? We're looking for how far did the car travel in this time. So again, we're looking for the change in x, okay, or the displacement. Okay, so we look through our equation sheets, we see which one has initial velocity, final velocity, time, and change in x. And so we're going to be using this equation, the change in x equals 1/2 vi plus vf times the time. Okay? So that has change in x, vi, vf, and t. Okay, that's what we want to use. Okay, then we just plug in what we know. So 1/2 times, in this case, the initial velocity was 5, the final velocity was 40, and the time was 10. So we plug that into our calculator. 0.5 times 5 plus 40 times 10. And we get that the car traveled a total of 225 meters. Again, because this is a change in x, or a displacement. Okay? So there we go. That's how far the car traveled in that time. So that's what we're going to be doing for this homework, is we're doing similar things as before, but we're identifying what we do and do not know, what we're looking for, and learning how to find the right equation to solve these problems. In class, I gave you a handout that showed you how to do this process. It was just kind of a reminder of how to do this method of identifying what you know and finding the equation that you need to use. Okay, this handout is on the website if you need it, and it's called How to Solve a Physics Problem. And again, it's just kind of the same steps that we've been doing here. Okay. But that's all we're covering for this podcast. Make sure you do the homework, the kinematics practice number 1. And hopefully that all made sense. Let me know if you have any questions, and thank you for watching.